Hello friends, today we are going to study how to plot a Bode plot. So basically, why do we use a Bode plot, or what are the advantages of a Bode plot? Using Bode plot we can get the gain margin and phase margin easily. Both low frequency and high frequency characteristics of a transfer functions can be plotted in one shown in one diagram, and the stability of a function can be also obtained easy. So what are the steps to plot a Bode plot? Let's take one example. G of s, h of s equals to k s plus z1 and s into divided by s into s plus p1. Alright. Now for using a Bode plot, there are certain steps. First we have to make this function into a standard form. So for that, g of s, h of s equals to k z1 into s upon z1 plus 1 and s into p1 s upon p1 plus 1. This is a standard form. Now we have to convert s equals to j omega, that is the transfer function, into frequency domain. Right? So let's do it. J omega and h of j omega equals to k z1 j omega upon z1 plus 1 and j omega p1 equals to j omega p1 plus 1. Now we have to plot a magnitude plot and phase plot table. Using this Bode table, we will draw a graph on a semi-log paper. This is a semi-log paper. We will plot the graph on this paper. Okay, let's take one sum. Consider this sum, a function g of s, h of s equals to 10 upon s plus 1, s plus 10. Alright. So first we will make it convert it into a standard form. The standard form is h of s, g of s, h of s equals to 10 upon s into s plus 1, 10 into s upon 10 plus 1. This is a standard form. Alright. Now now put s equals to j omega, g of j omega, h of j omega equals to 10 upon 10 j omega, as 10 cancel, j omega plus 1 and j omega upon 10 plus 1. Alright. Now the function would be 1 upon j omega plus 1 and j omega by 10 plus 1. Right? Now we have to consider the pole at origin. Pole at origin equals to 1 upon j omega, first order pole, equals to 1 upon j omega plus 1. First order pole, this is also a first order pole, equals to 1 upon j omega by 10 plus. Now a magnitude plot table. Magnitude plot table. Since here the value of k equals to 1, therefore 20 log dB log 0 base 10 and 0 equals to 0 dB. Therefore no shifting will take place. Alright. Now 1 upon j omega. So it will be minus 20 dB per decade passing through 0 dB, passing through 0 dB at omega equals to 1. Alright, then 1 upon j omega plus 1. This would be also minus 20 dB per decade passing, this would be minus 20 degree, there will be no passing when omega is greater than 1, and this will be j omega plus 1 divided by 10 equals to minus 20 dB per decade omega greater than 10. If there will be an 0, then it will if there will exist an 0, then it will be a 1 up something j omega plus 1, and it will be plus 20 dB. It would be plus 20 dB. Okay, remember this. Now this is your magnitude plot. Now let's for the phase plot. For phase plot, right? So phi equals to first write the equation. Here it is s, only s. So we will take minus 90, okay, minus, this is j omega, right? Tan inverse of omega minus tan inverse of omega by 10. Alright, if there will be a 0, then you will take plus tan inverse of something, whatever it will be. Alright, or if in this case if there will be a square, s square, then it will be a minus 180 degree. Remember this. Now what would be the value of phi? Find the value of phi. We have to put the value of omega phi. Now let's consider the value of omega equals to 0, 1. So the value of phi will be minus 96.28. If I consider it 1, it would be minus 140.71. 2, minus 164.74. 3, minus 178.26. and 4 minus 187.76. Okay, you can use your calculator to calculate it. Right, now using this table we have to plot a semilog. We have to plot a graph on a semilog paper. So let's take a graph. This is your semilog paper. See the scale. It's a non-linear scale, 1, 2, 3, 4, 5. You can make it as 0.1. This is 0.2 and so on, 0.3, 4, 8, 9 and 1. Alright. Then 2, 3, 4, 5, 6, 7, 8, 9, 10 and 20, 30, 40, 50, 60, 70, 80, 90, 100. Same way, this is 1000 and this is 10,000. Right. Now consider a 0 dB somewhere here. This would be 20 dB and this would be 40 dB. Below this it will be a minus 20 dB and minus 40 dB. Alright. Now here k equals to 1 equals to 20 log 10 equals to 0 dB. So at 0 dB you have to make a straight line. Okay, alright, now we will make a straight line. Now here I made a straight line over here. Now 1 upon j omega minus 120 dB per decade passing through 0 dB at omega equals to 1. So this is your omega equals to 1, and you have to make it to minus, you have to minus 120, that is towards minus 120 dB is given, that is towards downwards. Alright, so you have to make it till 1. Alright, let's do it. Now here it is given minus 20 dB when omega equals to 1. Now remember this minus, you have first taken minus 20 degree, here is also minus 20 degree. So club this, you will get a minus 40 dB. So now we have to draw a minus 40 dB line. That is take this one block this and one block this. You will require two blocks of minus 20 dB and minus 20 degree. That will make your minus 40 dB. Draw this way, minus 40 dB. Alright. Now here it is again minus 20 dB. So minus 120 dB, minus 120 dB, minus 120 dB, it will make minus 60 dB. So this will be 120 dB block, another 20 dB block, and this will be another 20 dB block. So extend it. This is your magnitude plot. Now you have to draw a phase plot. Consider over here minus 90 and minus 180. This would be your somewhere minus 270. So you have drawn here you have made your table over here. With depending on this table, you have to plot a graph. Now to avoid the confusion, I will mark this line with numbers. This would be minus 99, minus 108, next line, minus 117, minus 126, this would be minus 135, right? This would be 135, and this would be 144, 153, 162, 171 and 180. Now minus 96.28, it will be somewhere over at 0.1. 0.1 means this line. This is your 0.1 line. 96.28, that is between this is 96.28, then minus 140 and minus 140 at omega equals to 1, then omega equals to 1, then minus 140 would be somewhere here in between minus 135 and minus 144. So this is your minus 140. At omega equals to 2, it is minus 164. So minus this is the omega equals to 2 line, and it is 164, so it will be somewhere here, 164 at omega equals to 3. This is omega equals to 3, it is 178, so it will be 178, and omega equals to 4, it is 187, so it would be here. Alright, now draw a line passing through these points. This it is here. This is done. Now for gain margin and phase margin. For phase margin, you have to first plot omega GC. So omega GC equals to 1 radians. So when you draw magnitude plot, your magnitude plot which will coincide at a 0 dB, that point you have to take. So at 0 dB it is coincide at omega equals to 1, so it is 1 radians per second. Now phi equals to draw straight line from that point towards the phase plot you have drawn. It is minus 140.5 7 month. Now omega GC equals to 1 radians, phi equals to minus 145. Now phase margin. For phase margin 180 plus phi. So 180, this is my 40. Minus 140 we have got, so it will be minus. So 180 minus 140.71, or consider it as 140. You can consider it. So it equals to 40. Now for gain margin, you have to find omega PC. For gain margin, you have to find omega PC. Alright. So from here, the point which is meeting at 180 degree. Consider this line. GC, you have to take one point which is coinciding as 180 degree. So omega GC equals to what is this? What is the value of omega when your phase plot is coinciding with 180 degree? It is something about 3.5 radians per second. Alright. So equals to 3.5 radians per second. Now you have to get a magnitude m. So take the line upwards towards the magnitude plot. Where it is meeting this line, it is something minus 22. Right. So m equals to here, m equals to minus 22. Minus 22. For gain margin 0 minus m. This is the formula. So 0 minus of minus 22 equals to 22. This is your gain margin. So you have got your phase margin and gain margin. Now what about stability? If your gain margin, omega GC is less than omega PC, then it is a stable system. Or if your gain margin or phase margin are positive, then the system is stable. That's all. This is how we have to plot a Bode plot. Thank you for watching the video. If you want to see more videos, please subscribe my channel.